Well, we're just at the beginning of the Wildfire PIRE project in terms of collecting data. We have teams collecting different pieces of data, so it's different pieces of the puzzle. We're trying to understand how fire is responding to climate change, how it's responding to land use change. We're looking at fire in the past, we're looking at fire today, we're making projections about fire in the future. And all of these puzzle pieces are going to start coming together to make this great collage of fire science, and that's the goal of the project.
My name's Dave McWethy. I'm an assistant research professor at Montana State University. New Zealand is a really interesting place to work because New Zealand is the last place that humans colonized anywhere in the world. My research focuses on how humans alter natural fire regimes and vegetation and ecosystems.
Oh, look at that.
Whoa. Taking a column of mud out of these lakes is kind of fun because basically when you get that column of mud, it's like a history book in the past. Sometimes when we pull it out, we say, wow, this is when humans arrived, and you can see the charcoal from burning.
Charcoal analysis tells us about the fire history of an area, and really we can tease apart what's the interaction between climate and people when it comes to fire on the landscape. The past is really the key to the future, and so by seeing how things have responded in the past, we can better anticipate what is going to happen in the future under similar conditions.
My name's Cameron Nafisi. I'm a second-year doctoral student at the University of Colorado in the biogeography lab. What we're looking at are fires that have occurred over the past 100 to maybe 200 or 250 years. And essentially what we're interested in looking at is how the vegetation here has responded to those fires and how is it recovering from those fires. Caprasma 2.7, Conica 12.0. The big story here in New Zealand is that humans have had a very large role to play in wildfire in both the North and the South Island here. And that includes both the indigenous Maori populations that were here and the European settlers that came afterwards, both of whom burned quite a lot.
So a big part of my research here is studying the vegetation structure, the size distribution and height distribution, foliage distribution of the live trees. But along with that, we're collecting tree cores where we can look at the tree rings and find out the ages of the trees. When you drive around or look around the landscape, you can obviously see very strong effects of fire. I mean, is New Zealand becoming more flammable? And if, with a warmer climate, do we suspect to see more fire?
Every day is different, really. I think that's what's cool about projects like this. I'm Javier Fernandez. I just graduated from Texas A&M University. Our difficult sites are steep. Sometimes we have to do some crazy acrobatics through, trees or climb up and grab onto whatever we can.
Live Conica 31.9.
I'm an undergraduate research assistant, and so I help Alan and Cameron do all of the sampling. This has been a great opportunity for me. It's experienced a different ecosystem that's absolutely the opposite of what I would have experienced in Texas, and so I've learned a lot.
We're in one of the most southern landscapes on Earth. This is a very extreme environment. This strange land has a legacy of the vegetation that once clothed Antarctica. And one of the features of that vegetation is it seems to be particularly sensitive to very frequent burning.
So this is a Abrotanella silaginoides, a Kimberley pine, and it's one of about 10,000 dead Kimberley pines in this landscape. So obviously there's been a fire that's killed this tree. So the outer ring of the tree ring chronology that we find should give us a clue as to when these trees died. Yeah. So the pith should give us the establishment date of the tree, so when the tree started growing. And out here near Andreas's thumb should give us the date of the day the tree died, so when it got hit by fire.
And so we want to understand how much and where, and to some extent, these trees actually can survive or coexist with fire.
As an ecologist, admittedly it's quite exciting because I can see it's like it's a mystery to be solved. It's like, wow, look at all these dead trees and they're sort of ghost-like figures. But as someone who values, I'm a bushwalker and I love walking landscapes, so to see death and destruction all around is also quite disturbing, admittedly, and I think most people would admit to that.
I got started as a field researcher. You know, that's what draws you into the science, is just the love of nature and trying to figure out what's going on and walking around and making observations. And so it sort of centers me and is an important part of who I am. We're in Cradle Mountain National Park, and we're right at the transition between rainforest and drier forest in Tasmania. And so we go to lakes and we get vertical cores of sediment, starting with the present day and then going back to when the lake first started. And we study those sediments layer by layer to try to understand the history by looking at the pollen and the charcoal and the diatoms.
So this is present day?
That's the present day.
And then it goes back
It may well go back 2,000 or 3,000 years to the base.
My name's Simon Haberley and I'm an Associate Professor at the Department of Archaeology and Natural History at the Australian National University. I grew up in Tasmania on a dairy farm and have a sort of deep interest in this region, and I think as a child growing up, you look at the mountains and you just become awestruck by how massive and impressive they are. That sparked my curiosity about what the place was like in the past. Our main aim, I think, is to produce extremely high quality evidence that will tell us about the frequencies of fire and how climate will influence that. And once we can begin to understand that, we can then really start to make sensible decisions about what's going to happen in the future and how we might adapt to those changes.
Fire is like the canary in the coal mine today, and what we've seen in the last 20 years is more severe fires than we think has happened in recent history. And what gets me excited is trying to understand what's going on today by looking at the past, and hopefully the past can give us a better guide to the future.